Okay, so we are going to demonstrate my prototype here for my laser scanner using the David software version 2.6.1. So, let's fire it up. So, over here, we have a 9-volt, 16-amp CNC supply. Figured that was good enough. Our stepper motor is a NEMA 25 with a 99.5 to 1 planetary gearbox, a simple aluminum block milled out by Eric Dora from Ohio University. Thanks, buddy. A cheapo red line laser picked up from Axis Lasers, wired up. Everything is controlled by an Arduino AT Mega 1280. We have a Pololu A4983 stepper driver, heat sinked of course. We're pushing about 1.2 amps into the coil of our stepper motor. We have a 5-volt supply for the logic of the step driver and for our LCD. And then I have the classic LM316 for a 3-volt variable regulator for the LEDs to indicate it's on, and our laser over there. Our control is done by 3 simple arcade buttons. So when you first boot up the laser, you're greeted with the welcome to scanner, push OK screen. This is just so all the variables are in place before the program executes. Now, the reason for the calibrate is the actual scanning takes a painstaking long time, and it's kind of pointless to scan that entire plane. So before we can even start, I have to switch my menu around, but we're going to hit calibrate. And it waits for you to select the starting point. So we want to start just above the skull. So that's a good point. Gives us a point of how many steps that was. Click OK. Starting point was saved. Now the finishing point. Again, this is to save time. As you will see, the scanning process is painstakingly slow. Right now we're operating at full step mode just to quickly move the beam to its starting and finishing points. So we've hit the end. It's going to take 822 steps. Now when this is in scan mode, it drops the stepper down to quarter step mode. So it takes quite a long time. Reason for this is a more accurate scan, and here it returns to 0 in full step mode. Now if I can just get my software ready. Alright, now here's our software. It just right now is picking up pretty much what the camera sees. Fortunately, I can't take credit for it, but someday I can figure out, I guess MATLAB can do this. So we hit start. The software switches to pretty neat mode here. And when we come back to our little device here, it's kind of hard to see. Press and hold 1 for scan now. And it begins stepping in quarter step mode very slowly across our object. And if we look over here at our computer screen, we can see it slowly printing to the screen what the laser's picking up. Now this takes an incredibly long time. I don't expect anybody to sit through this entire process. Again, the reason for the slow scan is if we step in a higher mode or a faster rate, you will actually see lines in your object from the steps. That's how accurate this can be. The camera I'm running is a simple Logitech 900 Pro, I believe. I'm only inputting right now at 800 by 600 at 15 frames a second. Obviously a higher camera will yield better results, but the slower frame rate is tough to work with. You haven't quite figured out how to sync up the stepper motor with the camera's frame rate yet. We're getting there. Realistically, we'd be getting a better scan in complete darkness, but I just left the overhead light on here to show everything. We are almost done with this pass. Let's see what our LCD readout says. Scan complete. This is the point. It takes a few seconds to let the Pololu stepper cool down. It gets pretty hot pushing 1 amp. And then it will return to 0 pretty quick. So you can rotate the item and go to the next surface scan. Now down the road, I am adding a automated turntable, so as it's cooling and returning to 0, it will rotate the item 15-20 degrees. Other things I do need to add are a bigger LCD so I can make a more intuitive menu. So you can set step resolution, pulse rates. Also over here I have a TIP 120, which is going to be wired up to allow the Arduino to turn the laser on and off so that our line here doesn't sit on at all times. Also, next upgrade will be a green laser. CCD chips use 2 green pixels, 1 red and 1 blue. In this case, utilizing a green laser will give us more, basically, CCD space. So, those are some of the updates coming. And that's about it for now. This is the first pretty good test. The actual output, I gotta pause it. Our actual 3D output is this. And you can see we can move it around. I don't have a mouse hooked up, so I don't know how this is gonna work. But that is our 3D item. A little rough around the edges, but cleans up pretty nicely in other software. So, thanks for watching, guys.